Hey everybody, welcome to Science. We've got two recordings for you to look at here, and this is the first one. We're going to be talking about Newton's first law of motion in this recording here. But first, I want you to download the Cornell Notes attachment to the Kmail that this video link was on. Open it and either type into it or print it so you can print it out so you can take notes. So right now, pause the video until you're ready to start taking notes. Okay, first let's talk about your assignments for this week. We've got a grade check assignment to do, and yesterday was lesson 2.05. Today we're doing both 2.05 and 2.06 for Newton's first and second laws of motion. Tomorrow we get into the third law of motion, and then on Thursday and Friday we're going to be dealing with your next lab, which is all about forces and motion. So get ready for that. So we're going to talk about the grade check assignment next. So let's check that out. Where do you find that? Well, go to your science course homepage, go to the grade check assignment and open that up. And here are all the instructions. You're going to go to doc sharing, download and open and print out that assignment, fill it all in. Work with your learning coach to find the grades and percentages in each of your courses. Then you're going to go to the Dropbox for each of your courses and send it in there to your English class, history class, science class, etc. So that tells all your teachers that you and your learning coach know where to find your grades, and it'll really help you be organized. Here's what we're going to do today. We're going to review a little bit of what we did last time. We're going to talk about how to take notes for your science class, and we're going to learn about Newton's first law of motion. So get out that piece of paper and something to write with, or you can type notes into your computer right now. So last time we talked about acceleration and forces. And here's something real important that I want you to be sure you know about, and it's the relationship between force and gravity and weight. We're going to work on all that. So there's a unit of force called a Newton. That's the metric unit, System International unit of force. How hard something is pushing on something or pulling on something. That's a Newton, named after our friend Isaac Newton, of course. So 1 Newton of net force causes a 1 kilogram object to experience an acceleration of 1 meter per second squared. That means it'll speed up or slow down 1 meter per second every second. And you can also represent it with this formula here. Now, gravity itself is a force that can be measured as acceleration, because when something is falling, it's always accelerating, and it's falling on Earth with an acceleration of, and this is gravity here, 9.8 meters per second squared. So every second it's falling, it's speeding up by 9.8 meters per second. Now think about this. How is mass measured? What units do you use to measure mass? Well, it's kilograms or grams, right? So if you combine the mass of an object with the force of gravity, multiply 1 kilogram times the force of gravity, then what do you get? Well, you get an amount of force that's operating, the gravitational force on that 1 kilogram object. So that's going to be about, in this case, 1 kilogram is going to be 98. Okay, 98 what? We're talking about a unit of force, right? And that unit of force is a Newton. So we're using Newtons, we're measuring the force of gravity on this object, and so what we're finding out here is weight. This is the difference between mass and weight. Mass is how much matter there is in an object, how much stuff. In this case it's 1 kilogram. However, weight, that's the force of gravity affecting that object. That is weight. and that would be 98 newtons. That's the weight of a 1 kilogram object. Okay, so in metric system, weight is measured in what? In newtons. We're talking about newtons here, okay? So, moving right along, here today we're going to talk about Newton's first law of motion, and you're going to be able to understand inertia. So, the first law of motion is simply that you need force to change an object's velocity. That's all there is to it. There has to be a force involved. Now next, I want you to pause the video and write these words in the left column of your notes here. Okay? These key words. So pause the tape, pause the video and write these down right now. Okay, so here's another question for you. True or false? No force is required to move an object in space because there's no gravity. What do you think about that? Well, anywhere there's mass, there's gravity, okay? A force is always required to change an object's velocity, that's speed and or direction. The object has mass, even in space. But once something is moving, there's no friction or air resistance to slow it down. So once you push on something, it keeps on going forever. Unless there's another force on it. There's gravitational forces and so on out in space. But there's no air resistance, there's no gravity to drag it down along the ground. So here's a definition for you to write on your notes. Gravity is the force of attraction between all masses in the universe. Here's another way to look at Newton's first law. An object at rest will remain at rest, and an object in motion will remain in motion with the same speed and direction unless acting on by another force. And remember, you can pause and rewind to this tape to make sure you understand everything here. Now, sometimes Newton's first law is called the law of inertia. And inertia, here's another key word to write this down. Write this down. The tendency of an object to resist changes in its state of motion. This guy continues to move, right? He continues to move even though his motorcycle stopped rather suddenly here, okay? Inertia. An object at rest tends to stay at rest unless acted on by an outside force. And it's going to keep moving unless it's acted on by an outside force. In the case of this guy, that outside force was the car acting on his motorcycle, but he hasn't run into anything yet. Okay, so check this out. All right, I've got, whoops, and I dropped it. Hold on a second. Where did it go? I dropped my card. Oh, here it is. All right, so I've got a quarter here, a quarter, and a note card, and a glass, okay? And I put the note card on the glass, the coin, the quarter on the note card. What do you think is going to happen if I flick the card out of the way? Okay, let's find out. Okay, so you see here, the quarter dropped straight down into the cup, right? Straight down. So why did that happen? What force was operating on the cup? I mean, on the coin. What force was operating on that coin to cause it to simply drop down instead of going in the direction of the force? And can you think of other examples of Newton's first law? See, what was happening is there was very little friction acting on the coin as the card moved across. So the only force operating on the coin here was gravity. And that's why that just fell down, you know. Another example is pulling a tablecloth out from under stuff that's on a table. Don't do that at home. Your parents might get upset. But can you think of other examples of things that keep on moving in a straight line unless another force operates on them? Okay, next we're going to talk about acceleration, and that's another key word here, right? So acceleration is a change in velocity. What's velocity? Velocity is motion with direction, okay? So a change of velocity means either speeding up, slowing down, or changing direction. So a turn can be considered acceleration. Slowing down, acceleration. Speeding up, acceleration, or any combination of those. A change in speed and or a change in direction. That's acceleration. So I want to encourage you to go to the lesson. We're going to go there real quick. We don't really have time to demonstrate too much of this, but you can go to the lesson and check out these cool simulations. They actually are pretty cool here. Let's try and get there. Okay, so whoops. So you can try this out for yourself. You can launch this puppy and see what happens to it. And there are other demonstrations here as well. There's nothing to stop that, so it just keeps on going. Went right off the screen. Okay, and there's some other things to play with as far as constant thrust goes. Nice little video game format. So try that out for yourself. Here's a question for you. Once out in space, the space shuttle needs to keep going in the same direction at the same speed. Needs to do what? Sorry. Needs to do what to keep going in the same direction at the same speed? A, turn off its engines. B, continue to fire its engines. C, fire its engines intermittently, that means every so often. Or D, gradually slow the engines down. What does it need to do to keep going in the same direction at the same speed? And the answer is simply turn off its engines. Why? Because out in space, an object is going to just keep on going in a straight line unless there's another force acting on it. So if the space shuttle wants to keep going in the same direction at the same speed, you just turn off the engines. There's no other forces. Any kind of force is going to cause acceleration. If it continues to fire its engines, what do you think is going to happen to it? Okay, and here's what your notes should look like by now. Okay, so pause the video and make sure that your notes match what's on here. All right, this is a Far Side cartoon from back in the 90s, and we're going to change gears here just for a moment. I want you to take we're almost done here. I want you to take the 2.05 quiz, review the lesson, play those games, take the quiz. The keyword for attendance points today is inertia. I-N-E-R-T-I-A, inertia. And here's how you enter your attendance. You click on Dropbox, submit an assignment, look for Unit 2, CC Attendance Unit 2, Basket. Open that up, type inertia in the comment box, then click on Submit Assignment. Next time is Newton's second law of motion. What is it? Okay, thanks a lot. Thanks for playing, and don't forget to watch the next recording.